This is review video 50, what is titration? So we've talked about titrations before. They're a lab technique, you've even done one before. But what they are used for is to take a solution of a known concentration and you use it to figure out the concentration of a different solution that you do not know the concentration for. So there's a couple of terms which again you've already been introduced to. We have a titrant, and that titrant is your solution of known concentration. We have an analyte, which is your solution of unknown concentration. And when you put those together, you can hit an equivalence point, which basically means your moles of hydrogen or hydronium are going to equal your moles of hydroxide. And basically, when you've taken your analyte and it completely neutralized it with your titrant, that's your equivalence point. So a couple of things about that. Our strong acid and strong base titration, so that's the one that you've already practiced with, they have equivalence points that have a pH of roughly 7 in a perfect world with no error. And the reason for that is because a strong acid and a strong base perfectly neutralize one another, and there's nothing left over to throw off the pH at your equivalence point. However, if you're titrating a weak acid with a strong base, your equivalence point actually has a pH of above 7. And the reason for that is because weak acids have conjugate bases. And conjugate bases for weak acids tend to be a little bit stronger. And so the presence of that conjugate base pushes your pH higher than 7 when you reach equivalence. And it's the same thing but opposite if you're titrating a weak base with a strong acid. Weak bases have conjugate acids that are a little bit stronger. And so the pH at equivalence for that type of titration is a little bit less than 7 for that reason. Okay, so to just look at that conceptually, we see that when we put a weak acid into water, we're going to generate some H3O+, but we also generate this conjugate base. And that conjugate base is a little bit stronger because the original acid was weaker. As to why, we have to kind of dive deep into the theory of chemistry, and you do not need to understand or know why for the AP test. So just suffice it to say that weak acids have stronger conjugate bases. And the same thing goes for weak bases. They have stronger conjugate acids. Okay? Last thing you need to be aware of is your end point on your titration, which is something that occurs when your indicator fully changes color. So when we did the practice titration before winter break, you started with your clear solution that was acidic over here, and then when you hit your end point or you went a little bit too far, we had a bright pink solution because that phenolphthalein changed color. All right? So to just take a quick look at this titration graph so that you know what's what, we know already that our titrants are the thing that we know the concentration of goes in the burette up here. We know that our analyte, the thing that we do not know the concentration of, goes in the Erlenmeyer down there. And when we graph data like that out, if our analyte happens to be an acid, like acetic acid here, we're going to start low. So our starting pH is pretty low. And then as we start adding our base, our titrant to it, we're going to see that pH slowly climb until we reach this vertical section here. And in the middle of that vertical section, we have our equivalence point. If we keep adding our titrant base, eventually we're going to hit an end point up there. All right? If you have any questions about any of this or you need a refresher on titrations, please ask me in class.